Hello children, welcome to Zero Panic Maths. Okay, now in today's session, let us continue our discussion on the next concept from the introduction to linear polynomials, that is linear growth and linear decay. Okay, now in the previous session, we have discussed some concept on the linear patterns and the examples and the exercise set based on that. Okay, so if you have not watched that video, I suggest you to please watch that video, because there we have discussed a lot of such examples which will actually help us in understanding these concepts of growth and decay in the linear patterns. Okay, so the link is given in the description. You can watch that video. Okay, now let us continue our discussion quickly on the linear growth and linear decay. Okay, now as the name indicates, the growth and decay, it is growth means the increase in the value and decay is the decrease in the value. Okay, that is the simple concept behind this. Okay, now let us take an example to understand what is growth and what is decay. Okay, now see what the example 9 says. The cost of a journey is given by the linear function c of d is equal to 100 plus 60d. Okay, where CE indicates the total cost in rupees. Okay, C is the cost in rupees and D is the distance traveled. Okay, that is why it is said the cost of traveling a distance D. Okay, in kilometers, distance in kilometers. Now let us make a table of values for varying D from 0 to n. So you are traveling a distance from 0 kilometer to 10 kilometers. Of course, this table has given only the 5 values. You can calculate the other remaining 5 values from 6 to 10 also. Okay, and show how the cost increases for every kilometer. See, here it is said that how the cost depends on the distance that is traveled. Okay, there is a simple information given regarding how to calculate the cost of the distance traveled. Okay, what is that formula? Formula is this: C of D. With the increase in D, we need to calculate the cost incurred to that. Okay, and how do we calculate? 100 is the fixed charge. Okay, and for every kilometer traveled, it is 60 rupees additionally charged. That is what that algebraic equation says. Okay, now let us look at the table here. Distance traveled, which is in kilometers, D in kilometers. For 0 kilometers, this is the cost in rupees represented by C. Okay, it is 100 rupees because 100 rupees is fixed. Okay, and after that, for every 1 kilometer there is a 60 rupees increase in this. You can see that for 1 kilometer. So how did this is calculated is C of D, that is C of 1. When D is equal to 1, you're going to substitute that value 1 in this equation. Okay, 100 plus 60 into D. C of 1 is cost of traveling 1 kilometer. Okay, and what is that? 100 plus 60, that is 160. Now similarly, C of 2, that is cost of traveling 2 kilometers. Okay, you are going to just replace that D by 2. Okay, 60 into 2, this is 120, and plus 100, this is going to give you 220. Okay, so in the similar manner, you're going to put the different values of D and going to calculate the cost of the distance traveled in rupees. Okay, now if you observe that this looks like an example of a linear growth. Why this is called as a linear growth? See, it says as the value of D increases, by 1 kilometer, see, 1 kilometer it is going to increase. The value of the cost function C, increases by a fixed amount, and that fixed amount is 60 rupees. Okay, it's a simple example. You can see that the difference in each of these consecutive values is only 60 rupees. Okay, of course it is based on this equation, and only 60 rupees is going to be increased. So this constant increase in the value of one quantity, that is cost here, due to the change in another quantity in the given expression is called as linear growth. Okay, why it is called as linear? Because the growth is constant. Okay, and that constant is 60 rupees here. Okay, hope you understood this. Now we will see another example where there is a linear decay. Again, it is the same concept that is there in the linear decay also, but instead of the constant increase in the amount, it is going to be constant decrease in one quantity. Okay, let us see another example. Okay, now example 10 says the height of water in a cylindrical tank. Assume that there is a cylindrical tank, okay, and the height of water is 3 meter at the start of the summer. At the start of the summer, there is a tank, and the height of the water in that tank is 3 meters. Okay, initially 3 meters. So it is 0, 3 meters. The height h meter, height h meter, okay, m here is meter, okay, the height h meter at the end of t months, at the end of t months. So they have given a generic information here that when the height is when the months are t months are gone after the in the summer, then the height will be h meters. Okay, generic information is given by the linear function. And what is the linear function to calculate the height after t months have gone? Okay, after t number of months have gone, the equation is h of t, height for height after t months. You can say h of t can be read as height after t months, which is equal to 3 minus 0.5 into t. What is 0.5? It is the constant decrease. You can say 0.5 is half a meter. Okay, so for every t months, or for every 1 month, because the month t here is given in terms of 1, 2, 3, 4, 5. Okay, so for every 1 month, half a meter of water is spent, and that will be the decrease in the height of the water in the content, right? Water in the cylindrical tank. Okay, so that's why this equation is read as half a meter of water for every month is decreased by from the cylindrical tank. Okay, okay, now how do we represent the same information using the table? Is month in terms of t in the first row. See, for the 0th month, initially the cylindrical tank contains 3 meter of water, and height in the second row we are representing height h in terms of meters. Okay, after 1 month, the water that remains in the tank is 2.5. Okay, why? Because after 1 month it will be, see, h of 1. How do we calculate that? It is h of 1. In place of t, you just replace 1. Okay, so 3 minus 0.5 into 1. Okay, so if you subtract 0.5 from 3, it will be 2.5. Half meter is decreased. Similarly, for h of 2 means after 2 months, 1 meter will be reduced, and that will be equal to 0.5 into 2. 0.5 into 2 is 1, and 3 minus 1 is 2 meters. Or you can say from 2.5 you are subtracting 0.5 meters again, and it will be 2 meters. And 2 meters, another 0.5, 1.5 meter, another 0.5, it is 1 meter. So that way, if you observe, the height of water in the cylindrical tank is getting decreased by a constant amount, that is half a meter, 0.5 meters, with a change in value of t. Okay, so this is called as the decay in the linear pattern. Okay, linear decay. So this is an example of linear decay. In the example above, as the value of t increases, okay, this is what I have just explained. As the value of t increases by a fixed number, and what is that fixed number? Is 1 month. Okay, so by 1 month, when it is getting increased, the value of t, the value of the height h decreases. It is not increasing, it is decreases by a fixed number, and that fixed number is 0.5 meter. So that's why it is called as a linear decay. Okay, so in the next coming examples in the exercise set 2.4, we are asked to find out whether that example is a linear growth or linear decay. So based on this characteristic of linear growth and decay, we need to solve those problems and identify them as whether they represent a linear growth or linear decay. Understood? Okay, hope you understood this concept. Okay, now let us quickly move to the exercise set 2.4, which is based on linear growth and linear decay. Let us see what does the question number 1 says here. Okay, now it says suppose a plant has height 1.7 feet. Okay, the initial height is 1.7 feet and it grows by 0.5 feet each month. Okay, so there are two quantities here, that is the time in month and the increase the height in feet. Okay, so find the height after 7 months. So initially it is 1.75 feet. We need to find out the height after 7 months. The first sub question, we need to find out the height of the 7 months using 0.5 increase. It grows. Okay, 0.5 feet it increases every month. Okay, second question is make a table of values for t varying from 0 to 10. We need to make a table where the t varies from 0 to 10 months and show the height h increases. Okay, height h increases every month. Okay, let us do that table also and find an expression that relates h and t. Okay, now similar expression that we saw in the previous example, we need to define an expression that relates h and t and explain why it represents a linear growth. We need to explain that why it is called as a linear growth. Okay, it's a simple example. Okay, now let us start with the first part of this question, that is finding the height after 7 months. Okay, now the given is for every month it is 0.5 feet increase, right? So as an answer to the first question, given is growth in height growth in height is 0.5 feet per month, correct? So that is given. So therefore height after what is called as 7 months, after 7 months is the initial height plus the height the growth after 7 months, right? So that is initially it is 1.75. Okay, 1.75 plus per month it is 0.5 and after how many months they are asking? After 7 months they are asking. So it will be 1.75 plus 0.5 7 times is 3.5, correct? Okay, so it is 1 plus 3, that is 4, and 0.75 and 5, it is 1.25. So that will be 5.25 feet. Okay, so the height after 7 months, the height of the plant after the 7 months is 5.75 feet with a constant growth of 0.5 feet every month. Okay, so after 7 months, this is the answer. This is the answer to the first question. Now, second question that they are saying make a table of values t varying in this manner only, t varying from 0 to 10 months and show how height h increases every month. Let us see the table. Okay, now let us assume that this is the table and from 0 to 10 I have the month that is defined in term t as a month and h which is in feet, h representing height in feet. Okay, now initially for 0 months it is always 1.75 only. Okay, so it is 1.75 feet. It is 0 month means initially. Okay, now how did we calculated the month the height after 1 month? It is the initial height plus the increase in height after 1 month. Okay, so adding 0.5 to 1.75. Okay, that will be 2.25. Correct, 2.25. Now similarly, 1.75 after 2 months, it will be 0.5 multiplied by 2, and that will be 1, so it is 2.75. 2.75. Okay, similarly 1.75 after 3 months, it will be 0.5 3 times, which is 1.5 added to 1.75, that will be 3.25. Okay, now I expect you to fill in all these tables. Okay, I've given a table here. You can just go on doing the same calculation, and finally when we come at the 10th month, it will be 1.75, 0.5 into 10. Okay, that will actually give me 5 feet total increase, and initially it was 1.75, so it will be 6.75. Finally, you should get the value as 6.75 with a constant increase 0.5 every month. Okay, hope you will fill this table. Okay, so this is the answer to the second question, that they wanted a table containing this the constant growth. Okay, and finally the third question is, find an expression that relates h and t and explains why it represents a linear growth. Okay, now let us consider this as the third question. Okay, the expression uh, relating expression relating h and t, right? Relating h and t, okay, will be height after t months, right? It is height after t months. So I can write it as h of t, height after t months, is initial height plus 0.5 into t times. Okay, so how did we calculated all these values? The height, the growth in the height after every month is calculated by 1.75, considering this as a initial height, and then 0.5, which is t times. Okay, so this can be given as an expression that relates h to t. Okay, substituting t value, you're going to get all these values. So that is the first part of the third question. So that is this part, but they are again asked that why it represents a linear growth. We need to tell that also. So finally we can say that the linear pattern, or you can say the linear expression to the above is the linear expression. I can write it as h is equal to the height, h is equal to m t plus c. I'll tell you what exactly is h, because we wanted to find height. Okay, I'm writing it as h. And what is m or t? You know already that it is in months, time in months. And what is h in this case? Sorry, what is m in this case is the constant growth. I can write where m is equal to constant increase constant increase in value, constant increase in value, and that is equal to 0.5 feet. Okay, 0.5 feet. And c is equal to initial height. C is initial height, and what is that initial height? Is 1.75 feet. Okay, so you see that this is a linear equation. Okay, you remember the linear equation was of the form y is equal to ax plus b. You remember this format? Okay, the linear equation, initially we discussed on what is called as a linear equation. A linear equation is a algebraic equation in one variable x whose highest degree is 1, or the degree of that equation was 1, so it is x. So in terms of t we are representing, and m as a constant, and that is constant 0.5. so this equation is exactly similar to this only. Okay, you can see that this is c and this is m and t. It is mt plus c. So I'm just writing this mt plus c, mt plus c, so that I just converted this equation into the linear expression that represents a linear pattern in the increase in the value. Okay, so this says it is the constant increase, and this is the initial height, which is also constant. So therefore this expression represents a linear growth. So why did I explain all this? Because we have to say, we have to prove that this is a linear growth. So I can say, therefore this represents a linear growth. This represents a linear growth. This is the answer to this question. Okay, hope you understood this. So we will get some more examples of the similar kind where we need to prove whether it is a linear growth or linear decay. Okay, let us see the next problem. Okay, here also we need to prove the same thing. A mobile phone is bought for rupees 10,000. Okay, so that is the initial value, 10,000. Its value decreases. Here it is a linear decay, because they are saying it is the decrease in the value of rupees 800 every year. Actually this problem explains a concept of law of diminishing value. For anything that we purchase, the value of that will be decreased every year. Okay, so may it a car or a mobile, whatever you purchase, the value of that will go on decreasing every year, because it becomes second hand something like that. Okay, so that's why when a mobile is bought for 10,000 and its value decreases by 800 every year, the next year its value will be 800 minus into the 10,000. Find the value of the phone after 3 years. Okay, so for every year 800 it is decreases, so that after 3 years what will be the value of this mobile? That is the simple question, first thing. Second thing is, similar to the previous one, we need to make a table where the value of t, which is the time in years varying from 0 to 8 years, and show how the value of the phone, which is represented by v, depreciates with time. Okay, that is depreciation. That the decrease in the value of any quantity is called as depreciation. Okay, so find an expression that relates. Similarly, finally we did derived an expression. Okay, so similar to that, we need to derive an expression that relates v and t, and explain again why it represents linear decay. You understood this, right? Okay, now let us first go with the first question, that is to find the value of the phone after 3 years. Okay, now it is given that every year there will be a decrease in 800 decrease in the value by 800 rupees. So what will be the decrease in value after 3 years? Let us say, let the decrease in value after 8 years, after 3 years, right? After 3 years it is decrease in value after 3 years. It will be what it will be? It is 800, because per year 800 it will decrease, so it will be rupees 2400. Okay, rupees 2400. That is the decrease in value after 3 years. But what is asked here? It is the value of the phone that we need to find after 3 years. So therefore the value of phone, the value of phone after 3 years, after 3 years will be the initial value, that is 10,000, minus the decrease in the value, that is 2400. So that will be rupees 7,600. Correct? So the first question, the answer to the first question is 7600. It's a simple one. Okay, now let us look at the table with the second. Okay, now here the first column represents the time t in years varying from 0 to 8 as they have asked it. Okay, and the second column represents the value v represented in rupees. Okay, value in rupees. So what is the initial value for the 0th month? Means the initial value is 10,000 because there was no decrease in that. After 1 year, after 1 year, it will be 10,000 minus 800. Okay, so 10,000 minus 800 will be 9,200. Okay, after 1 year, it is 9,200. Again, after 2 years, it will be 10,000 minus 800, but that is 2 times. 800 2 times is 1600. So it will be 8,400. 8,400. So similarly, you will fill all these values. Okay, go on calculating 800 into 3, 800 into 4, and getting subtracted by from the value 10,000. So finally, when we reach the 8th year, I'll just write the value here, that 800 into 8. What is 800 into 8? Is 6400. That is 6400. So 6400, when you subtract from 10,000, what is the value that remains? Is 3600. Okay, so let us fill the table by calculating for every year. Okay, hope you will fill that. Okay, now what is the last question? Last question is find an expression that relates v and t. Okay, and we need to even prove that why it is why it represents a linear decay. Okay, now the third one, the equation relating the equation relating v and t. V and t, right? So it will be v of t, right? Value after t years. V of t is initial value was 10,000. Okay, and the depreciation, it is the depreciation, right? So how much value is the depreciation? Is 800 into t. Okay, so this is the equation that represents the relation between the value v and the time t. Okay, now let us see what is the linear expression, and you can say now the linear expression in the form of ax plus b. We need to write that also. Okay, the linear expression is the value, right? V is equal to mt plus c. Mt plus c. Okay, the linear expression that represents y is equal to ax plus b, where m, we need to write that m is constant decrease, right? Constant decrease in value, constant decrease, that is equal to minus 800. Okay, so every year 800 is getting decreased from the initial value 10,000. So that is a constant decrease. Now why I am writing it in terms of minus? Because I have to prove that this equation represents the linear decay. Okay, so and similarly, what is c? C is always the constant, that is the initial value, and that is equal to 10,000. Initial value which is equal to 10,000. So therefore finally this equation you can write, this represents a linear decay. Therefore, why it represents? Because there is a minus 800. Okay, this represents a linear decay. You can write that. Hope you are getting it. Why we are writing all this? Because the answer requires the descriptive way of explaining the things. You understood, right? Okay, now let us move quickly to the next problem. So this is also the similar kind of problem, we need to go through this and prove the similar things again and again. Okay. So the initial population, there is a village in which there are 750 people live currently. Okay. Every year, okay, every year 50 people move from nearby city to the village. Okay. There is a nearby city, and from there every year 50 people are coming to that village, where initially there were 750 people. Okay. And then 50 people every year coming in. It means 50 is the constant increase. That is what you can understand from this. Okay. Find the population of the village after 6 years. So we need to find the similar value. Only the values are getting changed here, but the questions are all of the similar pattern. Okay. Now second is make a table. Again, make a table of values t varying from 0 to 10 years. T is a time in years, and show the population increase, that is p, every year. Okay. And find an expression that relates p and t, and explain why it is a linear growth. They themselves are saying here it is a linear growth. Okay. So we can easily understand here how to resolve this problem. Okay. So the first part is, as usual, find the population of the village after 6 years. Okay. I can say that let increase in population, increase in population after 6 years. Okay. Every year it is how much it is getting increased is 50 people. 50 people are moving from city to village. So every year 50 people, and 6 years, after 6 years it will be 50 into 6, that is 300, right? 300 people are 300 is the value increased after 6 years. But what is the question asked here? Find the population of the village, which initially. So therefore population of village, population after 6 years, you can directly write after 6 years, population after 6 years is 750, which is the initial population, and increase in the population after 3 years is 300. So that is 1050 people. You can say 1050 people. That is the answer for the first question. Okay. This is the similar thing that we are doing for all the questions. So second thing is, with the same formula we are going to fill this table again by identifying what is the increase in the population every year. So here also the first column represents the time in years, second column represents the population p, okay, in numbers. So initially it is 750. Is it 750 only, right? So 750, and after 1 year there is a 50 increase in that. So after first year 750 plus 50, it is 800. Okay. After second year 750, 50 into 2, that is 100 plus 750, 850. Okay. You can just go on writing the same thing in terms of a linear pattern. Okay. 50 into 3 or 850 plus 50, that is 900. Okay. Similarly it is 950. You go on filling this. Okay. 1050, 1050. Okay. 1100, 1150, 1150, and 1200, and finally 1250. Okay. Now how did we derive this? Is 750 plus 50 into 10 after 10 years, right? After 10 years. So 50 into 10 is 500, added to 750, you will get 1250. That is 1250 people after 10 years. So this is the table as it is asked in the second question. Third question is, as usual, find an expression that relates p and t. Okay. Okay. So third question, the expression relating p and t. Expression relating p and t, where p is increase in the population or total population and t is the time. You can say the population after after t years is 750, which is the initial population, and 50 is the constant increase, and this is the t times. Okay, so this is the expression that relates time with population p. Similarly, we need to prove that it is a constant growth or linear growth. So the linear expression is linear expression relating both this. Okay, linear expression is p is equal to mt plus c. Only the same thing we are repeating, only this value at the left hand side is getting changing, whether p for population, v for value, okay, h for height. Okay, you might be observing this. Okay, where m is a constant growth, right? M is constant growth in population, constant increase, you can say constant increase in population, increase in population. Okay, and what is that? It is 50 people per year. And what is C? Is the initial population. C is the initial population. Okay, and that is 750. Now, why are we representing this as a linear expression? Because representing that as a linear expression and representing this constant value in terms of positive or negative actually allows us to decide whether it is a linear growth or linear decay. That is the reason we are writing this part. Okay, I think you are getting it. Okay, we have to write this part just to decide the last part of the third question. Okay, so therefore this represents a linear growth. You can say this represents a linear growth. We can write the same thing. Okay, you might be feeling the similar kind of problems we are solving. Okay, but this is what it is given in the exercise set. Okay, now let us see the similar kind of problem. Fourth problem. Okay, so read it carefully. The telecom company charges rupees 600 for a certain recharge scheme. Okay, assume that there is a mobile recharge scheme and they are charging 600 rupees for that recharge scheme. Okay, and this prepaid balance is reduced by rupees 15 each day after the recharge. Okay, so there's a simple information given that if you recharge 600 rupees, okay, every day there will be a deduction of 15 rupees from that 600 rupees. That is what the first line says. Okay, now let us see what is the problem. The first problem here is write an equation that models the remaining balance b of x. We have to write an expression b of x which is equal to b of x, and that represents remaining balance. Okay, so it looks like the third problem they have given it as a first problem here. Okay, so the remaining balance b of x after using the same scheme for x days. Okay, b of x represents the balance after x days. It means that. Okay, so explain why it represents a linear decay. So we have to, as usual, explain why it represents a linear decay just by representing that as a linear expression. Okay, so let us first answer the first question. The first question is remaining balance. So here we can say that remaining balance b of x is equal to, see what they are saying here is there was a recharge of 600. So initially there will be 600 rupees as an initial value, and for every day, and day is represented in x, right? So for every day 15 rupees is deducted, so it is b of x is equal to 600 minus 15x. So this is that expression that represents the remaining balance. That is the answer for the first part of this question. Okay, second part, they are asking explain why it represents a linear decay. So as usual, we need to represent this equation in terms of y is equal to ax plus b, that is a linear expression. Okay, and you can say the uh, linear expression is equal to linear expression. Also I can say actually represents the balance, right? So I will write it also equal to b of x only. Linear equation b of x is m t. So in terms of t, it is time is given in terms of x, that is days, right? So it is mx plus c. I can write this way. Okay, so this is the linear expression representing that, where m is the constant decrease in the balance, right? So where you can write where m is the constant decrease in balance. Okay, constant decrease in balance, and that is equal to minus 15 every day. Every day minus 15 rupees is getting decreased, right? And what is a c? C is the recharge amount. C is the recharge amount, or you can say recharge value. And what is that is equal to 600 rupees. Okay, so in this equation, if you put 600 as the value of c and minus 15 as a value of m, and go on putting the different values of x, 1 2 3, you are going to get the balance after 1 2 3 months and all that. Okay, so therefore we can say this is a constant decay or linear decay. So this, therefore, so this represents a linear decay. So this is the answer to the first question. This represents a linear decay. We need to answer this in this descriptive manner. So this is the first question. Second question is, how many days, after how many days will the balance will run out? It means how many days the balance will become zero. Okay, to spend 600 days. So let us consider this as equation 1. Okay, and using the equation 1, if you put balance is equal to 0 and find the value of x, that will be the number of days, right? X is the number of days. So in equation 1, if you put b of x is equal to 0 and find the value of x, that will actually give you the number of days after which the balance will become 0. Okay, so let us do that as a answer to the second question. Okay, second question, from equation 1, I can say from equation 1 we can say, we can consider, so that is balance is equal to 0, right? So I'll just write it in the way it was previously. Okay, and later we can convert it in the way we want it. Okay, so we can consider 0 is equal to 600 minus 15x as the equation to find the zero balance. I can say equation to find the zero balance. Okay, to find the zero balance. Okay, so you might ask me that why I'm writing in this descriptive manner, because the answer wants that descriptive answer. Okay, so here I can say 600 minus 15x is equal to 0. So this is 600 minus 15x is equal to 0. Therefore, sorry, I forgot x. Okay, so therefore if I take minus 15x to the right side, it will become 15x is equal to 600. Okay, so 15x is equal to 600 and x is equal to 600 divided by 15, and that is equal to 15 for the 60, right? So it is 40, right? X is equal to 40. So therefore after, the final answer should be after 40 days the balance will run out. Balance will run out. This is what they want as an answer to the second question. You understood this, right? Okay, now let us put the value of 40 here in x, or in equation 1 here in equation 1. 15 40 it is 600, and 600 minus 600, the balance b of x will become 0. That is the answer to the second question. Third question, as usual, they want a table of values for x varying from 1 to 10 days and showing the balance after every day. Okay, so there is a table already I have given here. Using the same equation, we need to find out the first column, days in x is given. The second column, the remaining balance b of x, we need to find out, and we know that b of x is 600 minus 15x. Okay, so after 1 day it is 600 minus 15 into 1, correct? So 600 minus 15, it is 585, correct? 585. Similarly, go on putting the same value here in terms of x. 15 into 2, that is 30, that is subtracted from 600, or 15 subtracted from 585, that is 570. Okay, similarly you just go on adding these values with 3, 4 and so on. Okay, just go on decreasing 15 rupees from this. Okay, 15 rupees from this, it is 555, this is 540. This way you just go on in decreasing the value by 15 after every day. Okay, so finally it will be 600 after 10 days. Okay, after doing all these calculations, you have to write that 15 into 10, that is 150, subtracted from 600, that is 450. Okay, so this is the table from 1 to 10. Okay, understood this? Okay, so now this completes the exercise set 2.4. Okay, I think we have a different concept as 2.5, that is finding the relationships, that is a linear relationship between x and y. Okay, let us continue on this concept and the problems related on this in the next session. Okay, thank you.